So let's start your snap for BEML, Raju. So as you mentioned, you want heat transfer snap today. So can you tell me something about the convection mode of heat transfer, Raju? How convection takes place? What is the mechanism of convection heat transfer?
Sir, basically convection heat transfer. Suppose one heated plate, uh, some air is such flowing over the heated plate. The heat transfer between the heated plate to the air, this type of heat transfer is called convection heat transfer.
Due
Sir,
to
actually,
convection, is it required
actually,
the heat transfer will be from from hot plate to the cold fluid? It may be from hot fluid to the cold surface also.
yes, sir.
So
It
I have
may
not
be
asked you
hot.
about I have not asked you about some example. I just asked you the mechanism of convection. How convection takes place at molecular level? Can you explain the mechanism of convection heat transfer?
Actually, sir, molecular level, bulk motion of the fluid. Actually,
Hmm?
bulk motion of the fluid.
क्या होता है वो बल्क मोशन? आप incomplete words मत बोलो राजू.
Sir,
Last time also I mentioned try to define completely. Okay. Every time interviewer is not going to tell you na ki
sir,
just add some more thing. You need to think, take some time and then answer completely.
sir, bulk
Again I am
motion.
repeating.
Some
Again I am repeating. You need to start from the beginning. Raju, what is a convection, a mechanism of convection heat transfer?
mechanism of convection heat transfer, bulk motion of the fluid. Some amount of energy is such a transport from the heated plate to cold fluid or cold body to such a heated plate.
So how bulk motion takes place? What's the difference between
Sir,
force and
actually,
convection?
bulk motion take place in two type of process. One is such a forced convection, and
Hmm?
one is natural convection. Due to forced convection, some external compressor or pump is feed into the system, and the fluid is such a forced. And the natural convection, due to the such a density difference, the fluid is such a transfer from a higher gradient to lower gradient.
What is Prandtl number? And what is the significance of Prandtl number in heat transfer?
Sir, actually, Prandtl number is the ratio between the ratio between the convection heat transfer to the conduction heat transfer. Sorry, sir. Prandtl number is the ratio of momentum diffusivity by thermal diffusivity, or thermal hydrodynamic boundary layer thickness divided by uh, thermal boundary layer thickness. Its value depend upon the one less than one or greater than one.
How much is the value of Prandtl number for water?
Sir, water exactly greater than one.
Greater than 1. Acha Raju, suppose we are using 1 kilowatt radiative coil
Yes, sir.
for maintaining some comfort condition inside a room. Suppose there is a winter case, the outside temperature is very high. So just to maintain some comfort temperature inside a particular room, you are using some 1 kilowatt radiative coil. Okay. So
Yes, sir.
now the room is in steady state.
Yes, sir.
Steady state means whatever heat we are getting from the radiative coil, that is actually the heat which room is losing. So you are maintaining your room at a some steady state temperature, for example. Okay. So that is known to us. For example, that steady state comfort temperature inside the room is suppose 25 degrees Celsius.
25 degrees centigrade.
We know the area of the coil and all other things also. Suppose we know the emissivity and other things. Then how you will find out the coil surface temperature?
Coil surface temperature. Sir, actually energy balance equation is required in this analysis.
Okay. How you write the energy balance equation? Good.
Conduction equals to conduction equals to convection plus radiation.
Just give me some equation. The equation which you
Conduction
feel you will be able to utilize for finding out the coil surface temperature.
coil surface temperature conduction K minus K dt by dx into area equal to HA T surface temperature minus T infinity plus sigma epsilon into A T surface to the power 4 minus T infinity to the power 4. In this equation, we get surface temperature of the
From
coil.
where you will get dt by dx?
Sir, dt by dx means T surface temperature of the coil minus T infinity by thickness of the coil by thermal conductivity into surface area of the coil.
You are taking the surface temperature, dt, as the surface temperature minus the fluid temperature. Are you sure? Between the surface and the fluid, the conduction is going to take place.
Sir,
That
actually,
is a free stream temperature, na?
Free stream temperature.
That is not the temperature of the layer which is just stagnant over the surface.
Sir, actually, molecular level, we consider the conduction equal to convection.
So if you are taking dt by dx as what, then how you can write dx? What dx you will take?
Sir, dx. Sir, actually, coil is a cylindrical shape, so coil. Actually, when I consider conduction,
again try to think. From this equation, you are not going to get the surface temperature. Try to think. I provided you sufficient inputs. The system is in steady state. 1 kilowatt radiative coil. You are maintaining the room temperature 25 degrees Celsius. Area of the coil is suppose known to us 0.5 meters square. Emissivity of the coil is also known to us. Suppose this is 0.8. Then try to think which equation you
sir,
will
actually,
utilize for finding out the surface temperature.
Sir, actually, we know the heat flux. So Q dot into surface area equals to convection plus radiation.
Which why you are taking convection actually? 3 or even more than times I mentioned, Raju, the radiative coil.
Sorry, sir.
I mentioned about the radiative coil. It means you can only, you need to consider only radiation. Why you are
only radiation? Sir, actually, we consider only radiation. We do not consider convection. Q dot into surface area equals to sigma epsilon into
what is that Q dot? What is that Q dot?
Q dot, सर Q dot नहीं होगा, Q होगा. वहाँ पर तो बोला है 25 किलोवाट का है. Q dot नहीं होगा, Q होगा.
25 किलोवाट? नो, मैं तो 1 किलोवाट का बोला है.
1 किलोवाट होगा. Q equal to sigma epsilon into A T s to the power 4 minus T infinity to the power 4.
Acha, just tell me, when you are writing that equation, sigma epsilon into area into T surface की power 4 minus T infinity की power 4. On what assumptions you are writing that equation?
Assumption. Sir, actually, this body not a black body. Epsilon not equals to. We consider, sir, in this given question, epsilon is not given. So we take epsilon equals to 1. It is such a, consider it is such a black body.
Raju, can you tell me something about Wien's displacement law?
Sir, Wien's displacement law is such a lambda into T equals to 2898 constant. Actually, wavelength inversely proportional to the temperature.
What is greenhouse effect?
Sir, greenhouse effect, larger wavelength can easily take into the room, but a shorter wavelength can easily get out from the cannot get out easily from the room. So
आप हिंदी में बताओ राजू, लेकिन अच्छे से explain करो.
Sir, shorter wavelength easily room से बाहर निकल नहीं सकता है, लेकिन longer wavelength easily room में घुस जाएगा, उसके बाद जो टेम्परेचर इंक्रीज होता है।
सोच के देखो, अच्छा सन से जो रेडिएशन आता है वो शॉर्टर होता है या लॉन्गर वेवलेंथ होता है?
सर वो सर शॉर्टर वेवलेंथ होता है।
तो शॉर्टर अंदर नहीं आ पाता?
शॉर्टर इजीली एंटर इनटू द रूम, longer cannot take place easily into the room, so temperature of the region is high.
आप ना बहुत इंटरप्टेड आंसर करते हो राजू, और इनकम्प्लीट आंसर करते हो। इसको थोड़ा समझने की कोशिश करो। उससे क्या होगा, इंटरव्यूअर को बहुत ज्यादा दिमाग लगाना पड़ेगा उसको सुनने के लिए, समझने के लिए आप, और वो कोई भी नहीं चाहता है। जब आप किसी से कम्युनिकेट करते हो, व्हाट एवरीवन वांट्स कि आप उस वो ही विल बी द पर्सन विद व्हिच यू आर इंटरेक्टिंग, if he is easily able to understand what you are communicating with to him, or what you are discussing with him. If he is easy, if it is easy to understand to him, then obviously that communication will be successful and he will be impressed with you.
Yes,
Are
sir.
you getting, Raju? तो थोड़ा सा इस पे ध्यान देना है आपको। I don't know how much you are working on that, but you need to put efforts. अच्छा मेरे को ये बताओ आप कि बायट नंबर होता है हीट ट्रांसफर में। What is the
Yes, sir.
significance of Biot number in heat transfer?
Sir, Biot number is a ratio of conduction resistance by convection resistance.
Mm-hmm.
Actually, it is useful for transient heat transfer conduction equation or transient heat transfer condition. When Biot number is less than 0.1, this is called a lump heat transfer analysis. When the uh, temperature does not depend upon the space, but temperature depend on the time in this condition.
आप बताओ, what do you understand by thermally developed flow?
क्या सर? सॉरी
What
सर.
is thermally developed flow? Thermally developed flow से आप क्या समझते हो राजू?
Sir, the thermally developed flow, at a certain distance flow is developing. After that flow is fully developed. Fully developed flow में temperature profile does not vary upon the length of the pipe or length of the slab. But developing region में temperature profile vary along the length or vary along the length of the pipe or length of the slab.
What is bulk mean temperature?
Sir, bulk mean temperature is the average temperature between the slab and the environmental temperature or environment temperature T infinity.
तो फिल्म टेम्परेचर में और बल्क मीन टेम्परेचर में क्या डिफरेंस है?
Sorry, sir. Bulk mean temperature is the mean temperature of the flow. Mean temperature of the flow, bulk mean temperature, it's depend upon the length of the pipe or length of the plate.
You know, conductivity of metals decreases with the increase in temperature. Why?
So conductivity, when the temperature increases, the molecular lattice vibration increases. Also the free electron movement is also increases. So free electron movement restricted the movement of the molecule, so the conductivity decreases.
ठीक है, ठीक है राजू, माय लास्ट क्वेश्चन टू यू। आप बताओ फिन का इफेक्टिवनेस क्या होता है? हाउ वी कैन डिफाइन द इफेक्टिवनेस ऑफ फिन?
Effectiveness of the fin is the ratio of Q actual. When fin use, the heat is transferred through the fin by when fin cannot we don't use the heat transfer through the fin. Ratio between these two is called fin effectiveness. Sir, its value always greater than 1.
Acha, why we prefer thin, wide and long fin?
Sir, effectiveness equals to, we know, mathematical formulation Pk by Ha, root over Pk by Ha. So when the P by A ratio is such less means fin is wider and thicker, or when the fin is wider and thickness is very less, then the effectiveness is very high. So we prefer wider and thick fin.
ठीक है राजू, मैं अभी आपको फीडबैक दे देता हूँ. देखो राजू, मेरे आपसे पहले भी मेरे ख्याल से दिस इज योर थर्ड आई फील फोर्थ स्नैप और थर्ड स्नैप.
यस सर, थर्ड स्नैप है.
तो आपका टेक्निकल अंडरस्टैंडिंग तो है, बट आपका जो डिलीवरी स्टाइल है ना, वो बहुत ज्यादा इफेक्टिव नहीं है. आप एक तो इंटरप्टेड आंसर करते हो, कंटिन्यूअस आंसर नहीं होते आपके. दूसरा, आप इनकम्प्लीट आंसर्स करते हो. थोड़ा सा उसको सोचो आप, और उस पर काम करो आप. ठीक है. तो जब आप किसी से डिस्कशन करो, लास्ट टाइम व्हाट आई सजेस्टेड यू कि आप थोड़ा टाइम लेके आंसर करो. थिंक फॉर ए व्हाइल एंड देन स्टार्ट आंसरिंग. जल्दबाजी मत करो आप.
यस सर.
जल्दी करोगे तो देन यू नो यू विल नॉट बी इन ए पोजीशन टू करेक्टली अंडरस्टैंड द इंटरव्यूअर व्हाट ही वांट्स एक्चुअली, बिकॉज आपको आंसर तो करना ही करना है, बट आंसर के साथ साथ आपको वो आंसर करना है द आंसर व्हिच एक्चुअली दैट इंटरव्यूअर वांट्स. आपको ऐसा आंसर कर रहे हो जो मे बी दैट मे बी करेक्टली टेक्निकली करेक्ट, but suppose interviewer don't want that. Are you getting? That is a human nature. तो आपको थोड़ा समझना पड़ेगा राजू, and you need to focus, you need to put some stress on that answer only. थोड़ा सा अंडरस्टैंडिंग आपको रखनी पड़ेगी, थोड़ा सा समझ के फिर आपको आंसर स्टार्ट करना है. एंड एक्सप्लेनेशन में एंड जस्ट आंसरिंग में देयर इज अ डिफरेंस. अभी तो आप सिर्फ आंसर में ही आप दिक्कत महसूस कर रहे हो, एक्सप्लेनेशन तो अभी है ही नहीं है. इंटरव्यू में सिलेक्शन सिर्फ आंसर से नहीं होगा, थोड़ा सा एक्सप्लेनेशन आपको करना पड़ेगा, आपको कन्विंस करना पड़ेगा इंटरव्यूअर को. राजू, आर यू गेटिंग?
सर क्या ये प्रैक्टिकल चीज से रिलेटेड करना पड़ेगा क्या?
थोड़ा सा एक तो आप इफेक्टिवली कम्युनिकेट किया करो बिना इंटरप्शंस के, एक फ्लो में. यू कैन गिव एग्जांपल्स, वो तो अच्छा ही रहता है. जब भी आप कभी एग्जांपल देते हो तो वो तो अच्छा ही रहता है, बट उससे पहले एटलीस्ट जो भी आप थ्योरेटिकल आंसर दे रहे हो उसको तो आपको कंप्लीटली आंसर करना पड़ेगा. लाइक आई आस्क्ड यू अबाउट ग्रीन हाउस इफेक्ट, तो आपको कैसे स्टार्ट करना चाहिए था? आपने क्या कहा कि सर खिड़की है, रूम है, उसमें से लॉन्गर रेडिएशन नहीं जा पाएगा, शॉर्ट आ जाएगा. ये दैट इज नॉट द वे एक्चुअली राजू टू एक्सप्लेन. आप क्या बोलोगे? सर ग्रीन हाउस इफेक्ट इज ए effect due to this particular effect, sir, the average temperature of the earth is increasing day by day, and due to that, sir, the glaciers are melting, and the sea level is continuously increasing, which is a major concern nowadays for us. So sir, how technically it occurs, let me explain you that, sir. तो अब फिर आप बताओ कि सर द हाई टेम्परेचर बॉडी लाइक सन दे emit radiations of shorter wavelength. Low temperature bodies like the earth, they emit radiations of longer wavelength. And sir, there are so many gases present in the earth atmosphere. Those gases are known as greenhouse gas, and they are having tendency to, they become transparent for the short radiations, short wavelength radiations coming from the high temperature body like sun, and they become opaque for the long wavelength radiations emitted by the low temperature body like earth. So due to that, sir, accumulation of the heat is continuously taking place, and due to that accumulation, the average temperature of the earth is increasing, rising, increasing day by day. ठीक है?
ठीक है.
तो थोड़ा सा समझो आपकी एक्सप्लेनेशन क्या करनी है. अब ऐसा नहीं कि आपको पता नहीं है राजू, पता तो है, अंडरस्टैंडिंग तो है.
सर मुझे पता है, लेकिन एक्सप्लेन करने में दिक्कत होता है.
धीरे धीरे थोड़ा उसको डेवलप करो, तभी देखो होगा अच्छा, तो तभी है ना, क्योंकि सिलेक्शन तो तभी मिलेगा. और नेक्स्ट टाइम इसका कुछ सिस्टम करके आओ, इसको पकड़ के ना बैठना पड़े आपको.
ठीक है सर.
एक्सप्रेशन को यूज करो, कंफर्टेबल हो जाओ. ठीक है. अभी ऐसे ही आवाज आ रही है आपका, बोल के देखो, अभी बोलो.
यस सर.
आवाज आपका बिल्कुल सही है. तो इसको ऐसे करके ही बैठना है और कम्युनिकेट करना है कॉन्फिडेंटली. ठीक है.
ठीक है सर.
इंप्रूवमेंट है आप में राजू. तो देयर आर सम पॉजिटिव चेंजेस इन यू आई एम ऑब्जर्विंग फ्रॉम लास्ट 2-3 स्नैप्स। तो प्रैक्टिस करोगे तो हो जाएगा, है ना। बट अभी डगर मुश्किल है, क्योंकि अभी मेहनत करनी पड़ेगी, मेहनत जारी रखनी पड़ेगी आपको राजू। But let me tell you, if you are working on, this particular problem of yours, you face difficulty in communicating, interacting with other persons. तो अगर आप इस पे काम करोगे, that will help you. Not in BEML interview, otherwise even in your daily life also.
Yes sir.
Because finally communication तो ऐसा होना चाहिए ना कि आप किसी से बात कर पाओ, कन्विंस कर पाओ, उसको समझा पाओ, ठीक है।
Yes sir. Yes
तो
sir.
बहुत ही पॉजिटिव माइंडसेट से लगे रहो, भिड़े रहो। बीईएमएल में भी होगा, और उससे अलग भी जीवन में बहुत अपॉर्चुनिटीज मिलेंगी, ठीक है।
ठीक है सर।
चलो मेहनत करते रहो, लेकिन, है ना। मैंने जो
ठीक है
बताया
सर,
था अपने
ठीक है
फ्रेंड्स
सर।
के साथ प्रैक्टिस कर रहे हो आप।
हाँ यस सर, प्रैक्टिस कर रहा हूँ।
चलो ठीक है राजू।
ठीक है, थैंक यू सर।